questions, I'll be sure to pass them on to Dr. Costello here midstream, or some we may save until the end. So with that, I think, David, if you want to click the screen ahead,
yeah.
I will make some formal introductions. Today's session is brought to you in part by Zorbitz by Carnegie Learning. That's who I'm representing today. Zorbitz, in case you're unfamiliar, is a blended learning platform that aims to support the entire teaching and learning process through a rich blend of play and pedagogy. Our contact information is there. If you had to pick one of those contact pieces, I would encourage you to follow us on Twitter because we share lots of really great resources all the time, tips and tricks, and it's a great community there. David is the founder of Costello Math. He is an educator and a principal from Prince Edward Island, author of at least 2 books, 2 that are published, and I think a third one is in the works. Is that right, David?
No, 3 are published, 2 with Pembroke and then 1 with Rubicon.
Okay, there it is. And so David's information is right there. He's given talks like this all across North America, and we're very pleased that he's found some time to join us today. So we're partnering with him. And one last piece of housekeeping. Some of you may have heard that at the end of the session, we're going to be giving out free copies, not just 1, not just 2, but if you manage to stick around for the entire session, and I know you're going to be on the edge of your seat the entire time because this is going to be such a great session. We're giving everyone, as a thank you for your time and dedication to bettering mathematical education, we're going to give everyone a free copy of David's book, Making Math Stick. So stick around till the very end. We'll make sure that you know how to get your free copy. With that, David, I'm gonna zip it, and I'll let you take it away.
Okay, thanks, Matt. Thank you everyone for coming. I know this is a busy time of year. Hoping that you have some takeaways from today's session that you can use on day 1. And like Matt was saying, this is coming from my book, Making Math Stick. And what I share in that book are practical ways that you can bring into the classroom, both in terms of instruction and student learning, that really make a difference. And they're manageable and sustainable. But to begin every session, I like doing some math. So on a piece of paper or on a piece of technology or in your mind, if you don't have any writing utensil with you, I would like you to draw an open number line for me. And why I'm using this is that you can use this anywhere from K through 8. And number lines we see a lot in the classroom, but I just want to kind of give you another way to approach number lines. Okay, so I see Matt holding up a number line. Now, here is my guess. I've never met many of you, but I want you in the chat box, if you could put yes or no. Is your number line horizontal? Just if you could put yes or no. Is your number line horizontal?
I'm getting a few yeses. Yes.
Yeah. So, and there's nothing absolutely wrong with that at all, but I just want you to think about in the classroom, when we're doing number lines, are we always using horizontal number lines? And I want you to have that food for thought, because we should have some flexibility in there so that students can see both horizontal and vertical number lines. Yeah, Matt, they were showing that. Now, this is how much confidence I had in that many people would do horizontal. I said start with 0 at the left of the number line. So if you can start with 0 at the left, put 0 there. Okay. Now what I want you to do is I want you to place the number 132 on the number line. Some of you are probably thinking, I'm not sure where to put it on the number line. And if we were in the classrooms, what I would do right now is that I would have you walking around and showing other people where you put the number 132, because the point being, you can put it anywhere on that number line and it's correct, because there's no other restriction in there. So we see where Matt put it, and some people might have put it in the same spot and some people might have put it in a different spot. And my question would be, why did you decide to put 132 there? And whether you were explicitly thinking about it or not, as soon as you put 132 some spot, you must have identified in your mind what the far number to the right was. So you would have done that range. But here is the change in approach I want you to think about to number lines. I want you to now place the number 150 at the far side, at the far right of your number line. So my question is, are you still feeling that 132 is in an accurate place on your number line? So this is what we would ask our students. Do you feel that 132 is in a fair spot? Do we need to adjust where you originally placed 132? Why or why not? These are the conversations I want to have with students, because instead of doing math, they're now thinking mathematically. And I want them to have that conversation, because we see a lot of times teachers give multiple questions, and they're constantly feeling the need to create many different questions, and they're not going deep enough with them. So instead of asking many questions, let's go deeply with one question. So it is the difference between going 1 mile wide and 1 inch deep, which is surface level, compared to going 1 inch wide and 1 mile deep, which is really digging into that. So that's what I would ask students, and I would ask them who needed to adjust where they placed the 132 and who didn't, because I want them to get into these questions other than when we give number lines. Here's 0, here's 150, where do you put 132? That really limits what the discourse is. So I want that conversation to be rich. So that's what I want you to think about. And it's a way of approaching number lines. You can do it with small whole numbers. You can do it with larger whole numbers. You can do it with real numbers, fractions, integers, decimals, and there's so many different ways you can do this. So this gets us into what the meat and potatoes is, and I'm from the East Coast, so then that's what I think of a meal, meat and potatoes. So I want you to think about the classes you are either teaching in or the classes that you support. We have many teachers who would hear this from time to time. My students spent a lot of time in the fall estimating with a referent. At first, we used concrete objects, but then over time moved to pictures. It's now winter, and when we ask them to estimate, the students count the items and then record this as their estimate. Now, this is a primary example, but this can be any concept. The point being, why do we see students who have demonstrated understanding earlier on in the year with a concept, but when we return to it later, they're now struggling with that? Why do we see that? And for an elementary example, this is one where the students did place value with decimal. At the start of the year, they did it with whole numbers. Then they moved to decimals, and they could do well with it. But before the second report card, the classroom teacher wanted some questions on the decimals as a way to review that and see how well students were doing with that. But the students needed quite a bit of support. And one particular student said, I usually get all the questions right in class, but I didn't this time. The teacher should review the concept with everyone before giving us questions. This is what we see in the classroom a lot. We hear students saying, I forget doing this. Or did we do that last year? Or the classic example from a grade 6 student, I don't think we ever did fractions before this year. And it's like, oh, yeah, you did, starting all the way back at grade 3. So I just want us to think, if we see this concern from one student or two, then it is a learning concern. But when we continuously hear this from year to year, I don't remember doing that, I forget, it's an instructional concern that we have to address. So this leads me to my question. How do you define learning? And it's a question that I think sometimes we take for granted that we have a conversation about. But how we define learning frames our approach to instruction and our approach to assessment. So how do we define learning? So think about that. How would you define learning? How do the teachers you work with or support define learning? And the traditional view of learning has been tending to focus on getting things into the heads of students. It's about getting things into students. And we hear things like, oh, you know what, that we have to cover this outcome, cover that. Well, that's about getting things into the heads of students. But you might think, well, we don't do that so much, David. That was kind of like the old transmissive approach. But think about how our system is still based and our system is still structured on this getting things into the heads. Our math curriculum and mathematical concepts are compartmentalized into individual topics. So they're put in individual silos where we do topic A, and that might be, let's say, measurement. We teach, test, and we move on. Then we go to topic B, teach, test, and move on. And then topic C, and so on. So it's very much a one and done linear approach. And if that's not bad enough, we actually further compartmentalize it into the actual concepts. When we're treating with the topics, we actually break those down even more. So let's think about a measurement. If you're teaching elementary, what we see is that the first few days might be about perimeter. So all the questions we give is on perimeter, all of our discussion is on perimeter, and then students practice that. Then another few days, we give area. Teachers and students focus on area. We dig down deep. Students practice with that, and we move on. And within each of these things, we see students who are doing well with them. But when we have block practice and when we only rely on block practice, that is causing us more harm than not. Because once again, think about a classroom where you do area, perimeter, and volume. When I give perimeter questions, students seem to do really well because they're only focusing on perimeter. So they're good. Then when I move to area, students do really well. They're good. Then when I move to volume, students do well and they're good. But what happens when I review them later on and I give a question that asks about perimeter? Students are confused which one to find. Do we multiply? Do we add? How do we find this? Because they've not been used to having to decide which strategy to use. And in this traditional view of learning, I want to give you a quick example. So when my niece was in junior high, they did multiplication, and I was supporting her with multiplication, but they were doing fractions. And she was struggling with the operations. So then what we did was we went over that and we went through that. So she came home with the test and said, look at this. I got a perfect score on it. I'm like, okay. Well, and the first 20 questions were like COL questions, like 1/5 multiplied by 7th, 9th, and whatnot. And then there was a word problem at the bottom. And the word problem was Vancouver Island was 1/7 the size of British Columbia. British Columbia is 1/10 the size of Canada. What is Vancouver Island in relation to Canada? So she multiplied 1/7 by 1/10. And I said, that is awesome. I said, how did you know to multiply? And she said, well, the first 20 questions were all multiplying fractions. And I saw 2 fractions in the word problem. So I just multiplied. I said, well, what would have happened if you would have had to add them? She said, David, it's a test on multiplication, and we spent 2 weeks on multiplication of fractions. Why would I have to add? And I'm like, okay. So this is a question. Based on this compartmentalizing approach we've taken, this block practice, does success really indicate understanding? She scored 100% on the test, but does that really mean that she understands multiplication of fractions and when to multiply? Retention and application are big concerns. We see a lot of students who are not retaining previous learning, and they're struggling with being able to apply that learning. And what's the takeaway? One and done. So I love this term, illusion of mastery, and you'll see it in my book, Making Math Stick. And what illusion of mastery really means is that we have many students who are, now look at my air quotes here, scoring well on assessments, but they're not necessarily understanding the concepts. And that's an illusion of mastery. Think about the classrooms you've been in. How many times do students come up to the teacher and say, is this right? Did I do it the right way? And they're relying on you to tell them if they're correct or not. We would never let that happen in literacy. So why do we do that in math class? Why do we let teachers tell students if they're correct or not instead of students monitoring comprehension? Because what we have to think about is the difference between an illusion of mastery and an accurate metacognition. When we only do the block practice, one and done, we have that illusion of mastery. Student thinks that they understand it because they're getting feedback that they do understand it, but it's really an illusion. We want students to have that accurate metacognition so that they know what do we know and what do we not yet know, and working through that. So we want students to be able to apply what they learned to new situations. So applying that previous learning, recognize the knowledge they have, and recognize areas that need additional focus. This is what we want for students. We don't want students to be really reliant on the teacher. And so we need to broaden the view of learning. So I will say learning is the acquisition of knowledge and skills. And we've done a really good job of doing that. And we focus a lot on that. But we also have to have these readily available from memory to support future meaning-making opportunity. Now, I'm really impressed with the technology, because look at what we did for this next slide. This is going to blow people's socks off. It's the exact same slide, but we just bolded the words. So that's the part that we need to acknowledge, that we need to do more work with. We need to have these readily available from memory so that students can support future meaning-making opportunities. Because think about how much time you've spent on concepts earlier in the school year, only to come back to them later into the school year and students don't remember doing them, or they can't apply that. What's the point then? And that's what we need to. We can't work any harder than what we're already doing. So we have to work smarter. Ooh, beautiful graphics. So what we have here is we have to appreciate that there's 3 stages of learning within this broadened view. In coding means getting information into the heads of students. It is when we're seeing it for the first time, whether through explicit instruction or whether through highlighting it in student work, but it's making them aware of them, aware of the concepts, having them understand it. And we've done that a lot in this manufacturing model of education from the beginning of schools. We have focused on getting information in. But about 30 or 40 or even 50 years ago, we've done a bit more work with the consolidation. That's when we add meaning and when we make connections with this new understanding and with this new knowledge. So that's when it sticks for us, when it actually becomes meaningful. So we've done a bit of work with that, and we're continuously doing that. But it's this 3rd stage that we've really struggled with, retrieval. Retrieval is about how do I support students in actually remembering previous learning and calling it back to mind. Because if we focus only on getting it into the heads and making it meaningful, if we never support students in being able to recall this learning, then they won't have it readily available to solve problems. And now I find this stuff riveting, but my lovely wife would be like, I don't know if I'd say riveting, but I do. Here is the whole cognitive science jargon. Each time a memory is retrieved, or each time you try to recall a memory, the individual must think about it one more time. You must reconstruct it in terms of what you knew about it and what you know now. And you reconsolidate it. So through that, the memory strengthens. So each time you try to recall something, you make that memory stronger. But the brain does something else that's really cool, is every time you recall a memory or you retrieve it, your brain realizes, okay, so this memory might be important. So your brain strengthens the pathways to it, and it increases the cues for that. So really, it makes it easier to recall. So the more that you recall a memory, the easier it becomes to recall that memory. So therefore, it can be argued that retrieval is actually more powerful learning than encoding. So really think about that. The more that you think about something from the past and recall it, it strengthens the memory. And the more you do that, your brain makes it easier to recall. Well, then it's such a powerful learning activity. And I see a chat come up, Matt. I don't know whether there's a question or.
Yes. So I'm now's a great time to mention to everyone that the chat problem has been fixed. The chat is now available. It looks like Bert has a question. It says, I lost sound. I'm going to try to reconnect. Oh, okay. It's just a technical issue, not a specific question.
Okay.
All right. But yeah, if you guys do have questions, the chat function is now operating. I saw a few things come in the Q&A saying, hey, the chat is disabled. It's now working. We got it fixed.
Perfect. So coming back to this, so then think about this, one and done, you do it at one time in the year and you never see it again. So your brain thinks, well, this really isn't important. important and we don't strengthen the memory. But the more times we have to revisit a concept, the stronger that becomes, and your brain organizes it in a way that makes it easier to find. So your questions might be, David, how do I retrieve this previous learning? Well, let me tell you, there's three really cornerstones to it. One is space practice, and you spread opportunities to interact with a concept over time. So instead of clumping them up, you can return to them over time. And that really interrupts the forgetting process. Mixed practice means in our practice sessions, instead of only focusing on one concept, focus on a few different concepts so that students must distinguish what the problem's about, what strategy do I use, and then apply that strategy. And feedback, students need to know whether their responses are correct or not. And this supports metacognition. So let's look at an example here. We are going to look at what we traditionally see in block practice versus a retrieval practice approach. So let's say that we've done concept A, B, C, and D. And let's say it's on place value, adding, subtracting, measurement, and geometry.
David, well, can I interrupt? Sorry, just before you get into the guts of this this example, because someone from Ontario just wrote in the chat saying this ties in well with our curriculum here in Ontario, intended to connect different concepts throughout the year. No more one and done. So anyone else who's dialing in from Ontario, this seems to be particularly relevant for the Ontario curriculum.
Yeah, absolutely. And what we're seeing is that there's different jurisdictions actually starting this work, and it might not be called retrieval, but they're actually starting it, and they're seeing significant difference and significant impact in terms of student achievement. So let's say we have those four concepts. Well, a block practice session would be traditionally one session would focus on concept A, one would focus on concept B, C, and D. And if people's thinking like, David, we really don't do that. Let's think about a classroom example. What tends to happen a few weeks before a provincial assessment? The instruction of new learning seems to stop. And I'm going to use this again, air quotes, we review, but we don't review, we cram, we throw everything against the wall and we spray and pray that it sticks. And that's block practice. That's why teachers feel the need to do that, because we've seen one and done and students have forgotten their previous learning. Well, that's not an effective use of time. So what I want to suggest is let's work smarter and not harder. So space and mixed practice would be, look at this, we still have the same amount of time. We still have the 4 sessions. We still have the same number of questions, but we're now mixing it. So each session has 4 concepts, but we're spacing the amount of time students interact with these concepts. So not only do they interrupt the forgetting process, but what they do is they actually have to stop and look through the problem and think, okay, what's this problem about? What strategy do I use and how do I solve it? Think about my niece who was working on the fractions. If I mixed practice and gave her problems that included adding, subtraction, multiplied, and divide, she would have to read through the problems and actually dig through them and work through them and understand, what do I use and when do I use it? So that's what we want. The space and mixed practice is an extremely important part of metacognition. Now, I will say, there is a time for block practice. When we're first introducing a concept, it makes sense to do block practice. But what I want to suggest is that we need to embed retrieval opportunities into our routines, that it'll make a substantial difference. And the thing that I've been working with schools and districts, and that I love about Zorbit's math too, is that we can do this in a way that aligns with any instructional model and with any curriculum as well. It really fits in there and it makes it meaningful. So the takeaway, before we get into the concrete examples, is many people think of retrieval as a knowledge check or as a dipstick to see if students know something, but it's more than that. It's a learning exercise that really supports learning. So what I want to do is I want to get into some some examples here. And before we start, I want to highlight these retrieval practice approach to do it. It can take as little as 2 to 4 minutes. They're not big and they're not time intensive. And it doesn't matter if you work with the workshop model in math, with the 3-part lesson plan, with a guided math, with a traditional mathematics lesson, with a centers approach. This retrieval practice can apply to any of those models. But what I'm going to suggest, now some of the curriculum people might say, oh no, but this is true. There's some math curriculum outcomes that are more important than others. There are, I know Matt is shocked, but there are. And those are the key concepts. And whether your district calls them key concepts, foundational outcomes, core concepts, core standards, key learnings, each of the grade level has those key concepts that make such a big difference and can help students learn other math concepts. So what my work with in some schools and districts has been to identify what these key concepts are. Because when we're doing retrieval practice, we're going to focus on the key concepts. So if you want to take a quick little snapshot or a picture, on the left, this was just an example of one group that I work with, that we identified this key concepts for this particular school and for this grade level based on their curriculum. And on the right is an intermediate example. Now, the powerful thing is that I could work with 4 different grade 5 teachers across different spots. They might identify different key concepts based on their students' needs and based on their assessment data. Now, while there will be similarities, there may be differences, and that's fine. But I just want you to kind of take that for the key concepts. We're going to focus on what are those key concepts and how do I use the key concepts to do retrieval practice.
David, I just want to interject for just a second. There's a bit of activity happening in the chat. One comment was made in retort to my comment about the Ontario curriculum, this being particularly relevant for that jurisdiction. There was comments as well for this being particularly relevant for the BC curriculum as well, yes, which I believe are currently undergoing some reform on their math curriculum. There's also some love talking about spiraling. Yes. Which I believe is probably, I'm sure there's nuances and the differences between what you're calling mixed practice and spiraling the curriculum. Yeah. I know you're going to get to that in a little bit. And there was another comment that made that this really promotes thinking about the math instead of just doing the math. Yes,
yes. This really, really moves from students who can just do it by rote into understanding. And to kind of make a connection to what literacy is, it is the difference between just being able to decode to being able to comprehend.
That makes perfect sense. And one thing I wanted to, again, before we move on, there was one thing that you said that I wanted to just kind of jump on here as well, is you made the comment of it being meaningful, right? If we're taking the transition from blocked practice to mixed practice, it puts any specific idea within a broader context where they're getting different aspects of the curriculum, kind of seeing that interconnectedness. And I think when a lot of people see the word practice, they immediately think to like the worksheet, right? So now instead of having a focused worksheet on one concept, which would be very easy to create, very easy to Google and find those resources, now we're talking about creating resources that cover the entire, well, a good chunk of the breadth of a curriculum, perhaps in one resource. And that may be stressful for a lot of teachers. But I think it's really key to really focus on that idea of meaningful, that those practice sheets, although they do have a place in learning and kind of solidifying the learning, I wanted to better understand when you talk about meaningful math, what does that mean? Like, what does block practice outside of like the traditional tests or worksheets? What does meaningful math look like?
Meaningful math is when students have to stop and think, what is this problem about? What strategy do I use? And how do I work through this? So then meaningful has an element of productive struggle within that. And when we actually dig down deeper, so retrieval practice is about making those previous learnings readily available. Because how many times when we give students a problem and we say, okay, does your work make sense? Well, if students haven't engaged in retrieval practice, then what they have to do is they're using all of their working memory on the minute details of, okay, how do I subtract? How do I add? And they're losing the sight of the problem as a whole. So when we lose the sight of the problem as a whole, then we can't judge the reasonableness of our work because we don't have anything to really tie it to. So whenever Matt's talking about practice and I'm talking about practice, I am talking about purposeful practice that's going to make a difference and that's going to help students move from just doing math to being able to think mathematically.
So this is where we start to bring in those 5 intertwined strands of mathematical
Yes.
proficiency, the productive reasoning or adaptive reasoning and all those pieces. And so putting math within a context.
Yeah.
Sorry, I just wanted to, when you said the word meaningful, I was like, I gotta, let's dig in on that for just a moment, but I'm gonna get out of the way again.
And that's a good point because what we found is that making math a stick and these retrieval practice approach has actually supported students with the social emotional learning pieces too, because they are able to productively work through the problem as opposed to non-productive struggle. So then what I have here is I have 4 strategies that we're going to go through: daily cumulative review, then now later check-ins and year plan. So let's start with daily cumulative review. It's already January 30th. Our first term's done. We're great. But what daily cumulative review is, it's an approach to retrieval practice that really takes about 5 to 8 minutes of your day. And what it is that questions, when we identify the key concepts, either based on the importance in the curriculum outcomes or based on our own student assessment data, we've identified key concepts and we're going to use those to do daily cumulative review. And daily cumulative review are 4 questions on 4 different concepts that we give at the start of every day math class. And we give students about 3 to 5 minutes to do those problems, even though it should take 3 to 4 minutes. And then the teacher records the solution on the board so that students get feedback. And it's on 4 different concepts. And I'm going to show you an example of what they are, but I just kind of want to break it down first into what it is, what it isn't. It engages students in thinking mathematically. It's not necessarily a prelude to the day's lesson. So like Matt and I had a great conversation about this. What I mean to prelude is that it's not necessarily on the same concept that what you're focusing on that day. This is independent of the main lesson focus. So if you're working on transformational geometry in your year plan at that point, this is independent of that. These are based on the key concepts so that students have multiple times to engage with those key concepts. It's 3 to 5 questions. The sweet spot is really 4 questions. Now, if you're teaching primary grade 1, you might go with less questions than that. But when you're in elementary and when you're in intermediate, 4 questions is the sweet spot. And they're on 4 different concepts, 1 question per concept. They're not all on the same concept. And you will see in this what we're doing. We are spacing that concept over time, but students are having multiple concepts within a practice session. And it strengthens retrieval. But they're not heavy duty time consuming exercises. We're not digging deep with this daily cumulative review. We're just practicing and we're just recalling previous learning, so our brain will strengthen that memory and it'll be easier to recall. So here would be an example of what daily cumulative review might look like. This left example was from a grade 2 teacher, and here were the 4 questions they put on the board: a before and after sequence, a number sequence, a word problem, a traditional word problem, and an addition fact. The grade 4 teacher, they gave these fractions and they wanted them to put on the number line. Then they wanted to arrange the numbers in descending order. a word problem, and a subtraction with decimals. And the grade 6, they wanted to place these decimals and fractions on a number line, multiplication, arrange fractions, and place value. So that was their 4 questions based on the 4 concepts that they identified. And here would be an example from the week. So you'll see on the left the primary example, and the teacher identified place value, perimeter, subtraction, and equations. So each day there was 4 questions, and there was 1 question on each of those concepts. And on the right, it's an intermediate example where they focus on fractions, place value, multiplication, and comparing numbers, fractions. So you can see how the questions are very similar from day to day, because it's not meant to dig deeply. It's meant to promote the recall so that you're not using all of your working memory on recalling previous learning. Instead, you can call it so you can focus on the problem. And I'm going to let Matt speak to this.
Yeah, so when we were having that conversation, my mind immediately went, when we're talking about like these daily cumulative reviews, or like the kickoff, not necessarily the prelude to the session, but a way to warm up students' brains and creative problem solving skills. My mind immediately went to our math talks. And I know that our good friend Hassan and Michelle and Adrian have invited some of our district partners here today. So as you're kind of supporting some of the teachers that may be using Zorbits in their classroom, I would encourage you to point them towards the resources library in their dashboard. And down the bottom, they can filter by math talks. And there are some rote activities that kind of mirror some of the ideas that were in David's example. But there's also some ideas in that are a little bit more open in terms of not necessarily lending themselves towards a specific strategy or recalling a specific skill from the past, but really, like, one of my favorites is the calculator is still good, right? Where you have this busted calculator and you got to make 45, but the 4 is busted, the 5 is busted, the plus sign is busted. So how do you do that? And so students really need to pull on all of those things that have been encoded and consolidated and really start to strengthen that pathway to retrieval to any number of strategies. So I just wanted to make that call out. There's a whole library of these things available, and they're some of my absolute favorite resources in the platform.
Oh, that's great. Yeah, and that kind of comes back to what we talked about earlier, working smarter, not harder, because everything's there to pull from. So this daily cumulative review, what I've seen in one particular school I was working with, it was a large school. They have implemented this, and the percentage increase on number of students meeting grade level expectations on their provincial assessment increased and has maintained a 19 to 20% increase. So it's really paying off, and they're seeing significant gains, and teachers are identifying it's not more work. It's just working smarter, and it's using questions we already have. So lessons learned from this: if you have more than 4 concepts, just kind of go through. You might do concept A, B, C, and D every second month, and concept E, F, G, H every other month. Facilitating daily cumulative review, it might be on a whiteboard where students record their answers and then they hold them up. Might be on a scribbler. It might be digitally. Crafting questions, don't start from scratch, similar levels, and monitoring progress. So here would be one example of a traditional old school. This is what I do. This is kind of like my grid that I put on a piece of paper on a clipboard, and then every week I'll make a little note quickly of a concept that the students are struggling with. So then over a few week period, or like over a term, I can see the progress, and I can see students, whether they have made gains with it or if they're still struggling with it. And there's opportunities to do this within Zorbits too that really make a big difference to help. And I'll let Matt speak to that.
Right. Yeah. So, I mean, one of the things we always say about this progress area is that it should never be used to replace a teacher's intuition or their own professional judgment, but it is a great sort of second set of eyes or a sounding board for validating some of those observations. So even though those grids where you're looking at each individual student and teachers are doing what they do best and really kind of watching for those cues, if there's an instance where, life happens in the classroom, right? It can be a chaotic and beautiful place. So it's very easy to miss some of those observations from different students, or to overlook that piece in a busy week. So this is a great sort of safety net for those sorts of observations, or that sort of data, because this is, as you can see up here in the top right corner, you can select a date range. So you can see like what happened last week. I completely forgot about that grid last week. So I can go see how are students doing on any given concept throughout that week. And it's not just one concept, it's any of those things that you've put into your rotation.
Awesome. And now strategy 2 would be a then, now, later grid. And what it is, it's a 3x3 array where the top row talks with the then concepts you previously explored. The middle row talks with concepts you're currently exploring. And the bottom row talks with concepts that'll be coming up. So the top 3 would be your then, current would be the now, the middle row, and the bottom row would be later. And what this does is you can make this on a Monday and post it either digitally or in a classroom on a piece of paper or on a chart, and they could have the week to solve these. But it gives students the opportunity to interact with different concepts and to return to previous learning. So they're not just one and done, but they're working through this. And it could be done weekly, it could be done every second week. And it's meant to be a strategy that doesn't put many demands on the teacher. Okay, instructional strategy 3 would be check-in. So then once again, what we've talked about, we don't want it to be one and done. So periodically checking in with students provides the teachers with valuable assessment data, but it also lets students re-engage with the concept. But however, we need to think about this sustainably. So only focusing on your key concepts within the check-in. So like here would be an example. If I have 6 key concepts, I would have 6 check-ins throughout the year. After the first key concept, let's say I teach place value, and after the first key concept, I give them a few questions on place value. But let's say that my next key concept is on measurement, and I don't do that for a few months down the road. At the end of that key concept, I give them a few questions on measurement, but I also tag in the previous key concept so that it's not just one and done. So we're always looping through them so that students have an opportunity to revisit the concept over time. And what we see is that the first time they see the concept, they do relatively well because it's in like a block practice and it's fresh in their mind. But when they see it again for the next time, it's kind of like, well, then what is this doing coming back? And their scores kind of plummet. But then over time, as they re-engage with that concept, their understanding of it becomes stronger. So this is a formative assessment opportunity, and it allows students to re-engage, but it's actually solidifying their understanding of the concept. And you're not doing this with every concept. Like I said, it's only like about, if you've got 5 key concepts, then you're only doing 5 check-ins. And I'm going to show you an example. So here would be check-in number 1. It would be the key concept for grade 3, show and describe numbers to 1,000. We got that. And then you can see when you pull from Zorbit's math, you could really set that up like a check-in. And let's say that is 3-digit addition right there. And then what we got is we have this activity that ties in with check-in number 1. And then what we have, now this is check-in number 2. Now you can see that this check-in key concept 2 was a skip counting forwards and backwards. So that's my question, but you can see with that rectangle, I'm also looping back in key concept 1, so they're having times to re-engage with it. And you'll see in Zorbit's math, they have 3-digit place value, that's their new one, but then they're looping in with 2 questions back on 3-digit addition, which is key concept 1. And there's their example right there. And the same for concept number 3, check-in number 3. This is their new key concept, adding and subtraction mental math, but see where they're leaping in the previous 2 key concepts. And you can do that using Zorbit's math. There would be the input screen, and there would be what students will encounter. So you can see that it's about working smarter, but students have multiple opportunities to come back to a concept. And I'm going to let Matt speak to this.
Yeah, so again, just speaking to the folks on the call who are supporting teachers currently using the platform, those examples are dead easy to create. There are some pre-built assignments in the dashboard, but creating that recurring piece that shows up at the end of the assignments is on the assignments page, and you just click create custom assignment, and teachers can add up to 10 activities within any given assignment. And then on their dashboard, on their homepage, they can see that schedule. So they can see perhaps this is a little bit more rapid fire than I think David is referring or would recommend that these things take place over. But just to kind of fit it onto the one screenshot, you can see exactly when these things are scheduled, so teachers can kind of get ahead of their lesson planning.
Awesome. And really, when you're thinking about looking back for like progress and trends, you get so much out of this because you can see it over time. And just the last one, and we're not going to go deep into this one just because we know it is August 25th, right before our school year, but we did want to plant this idea. One other way that you can do retrieval and to avoid that block practice is by spiraling a curriculum. And when we're thinking about spiraling a curriculum, we're not thinking in terms of individual outcomes, but we're thinking in terms of big ideas. So when we're grouping these individual outcomes into a big idea, and you might have 6 to 8 big ideas for your year. And what we do is your year is cut into thirds, where the first cycle through, you might go into each big idea. You're just getting your feet wet, like you're priming the pump. And then the second cycle through, you're actually going into a bit more, wading in a bit deeper. But the third cycle through is you're actually going into a much more complex problem solving way. And I will say, some people say, you expect us to get 3 cycles in when it's a struggle to do 1? But trust me, what the focus on spiraling curriculum is changes from coverage of the outcomes to a focus on student learning. So if you or your board needs help with that, let me know, because we've seen significant gains in terms of student achievement and in terms of teaching practice about how spiraling curriculum works. And just my website for support, if you go to costellomath.com, you can see instructional videos. I have problems of the week and problem solving. I have a blog posted on there in Classroom Connections, and there's a spot where you can subscribe. So I'll let you know when we get new postings on there, costellomath.com. Everything's for free. Très bien. And there is our contact information. Zorbit's on the left. I believe Matt said the best way to get a hold of them is through Twitter at ZorbitsMath. And there's my information on the right, david@costellomath.com. That's my email. You can follow me on Twitter at Dr._Costello, or the website at costellomath.com. And I'm going to send it over to Matt for the giveaway and questions.
All right. Thank you very much, David. So with that, does anyone have any specific questions for David? We've got about 8 minutes before we officially run out of time. If you have any questions, don't hesitate to type it in the chat or in the Q&A.
Yeah, and just once again, I should say, what we're sharing here, both from my perspective, making math stick, and from Zorbit's Math, is that these are not time-consuming exercises. This is not time-consuming work. This is about ways to support our teachers in the classroom so that they can support their students. And they'll really see an impact in terms of student learning. So I would love to hear how it goes. And okay.
So I do have a question here.
Oh.
Jason Council is asking, do students get bored or frustrated seeing the same topics come up through the year?
At first, no, they don't, because there's a few things. You can really rotate through the different key concepts, and you could do it like every second month and whatnot. That's one. But what we found is that students come to see what the rationale is, because at first they might think, but we really didn't do this, so why are we doing it now? But then they see over time that they're able to use that concept. And really, how I view it into it is when we don't have to do all this cramming, because think about what we traditionally do before a test when we were going through university. We would cram everything, right? We would cram everything, and then we would do it, but then we would have that illusion of mastery, and we weren't sure how well we were doing. This really supports metacognition, which then gives students confidence and to be able to work through a problem. So no, it works well. And now there's some people that might do daily cumulative review every second day. They might not do it every day. They might do it every second day, and every other day they might do a number talk and something like that. They're kind of working it through there.
Yeah, I've heard it said, math talks can be difficult to work into a busy schedule in certain contexts. So I've heard people implement things like Math Talk Monday, right?
Yeah.
Where every Monday there's that level of predictability. This is what math class is going to look like today versus tomorrow versus Wednesday, and that graph you showed, where like when they first get tested on something, they do quite well because it's familiar and it's immediate, it's in their working memory. But then the second time they see it, then immediately drops off. And it's funny because that's kind of, I think, why in so many educational circumstances, and I feel seen in your comment about cramming for university, David, like that's often the second time we encounter that concept, and that's often the high stakes evaluation.
Yes.
Right? Or the next year. So I think it's important to like at least offer 3 or 4 to kind of get out of that little trench, right?
Yeah.
And so I think that was a really powerful sort of data point for myself in particular.
Yeah.
I'm scanning through the chat here. I don't see many other questions. I am looking forward to hearing what everyone thinks of the book and of today's session. If you have any thoughts or want to get in touch with us, please don't hesitate to reach out. The contact information was there. David, would you mind bringing that up one more time before we clue up?
Yeah.
And if you, it would mean the world to I know David and us at Zorbits Math, if you wouldn't mind taking a moment to just kind of tweet the one takeaway that you took from today on Twitter and tag us at Zorbits Math and at Dr._Costello. We would love to hear what was the one thing, if nothing else, what was the one thing you took away from today's session? We'd love to start that conversation in our communities. All right, so we're seeing a lot of thank yous in the chat. Thank you very much, everyone, for your time and your participation today. Sorry